Hello, welcome to chapter 3, where we're going to do lots of fun stuff. Let's get started. All right, here we go. I'm going to try something a little bit new. You'll notice that most of the stuff is already filled in. I'm trying to cut down on you all just watching me write stuff. So, we'll see how it goes. But anyway, welcome to 3.1, first section in chapter 3. And we're going to talk about these piecewise functions. And that's just a fancy vocabulary word for you're just going to take different sections and you're going to have a different function for each one of those sections. So here's your definition. A piecewise function is made up of two or more functions. And you'll notice, here's our example. You'll notice that you have a function. Okay, we're kind of used to those. But we also have this if statement. So this is the function that you're using if x is less than negative 2. So if we had a number line, everything less than negative 2, we would use this function. And everything bigger than negative 2 or equal to, we would use this function. And that's basically it. That's this whole section. Now, I'm going to tell you right now that it's an easy concept, but it can get pretty frustrating when we get into the weeds. But here we go. So our first example, we are just trying to evaluate this number in our f of x. Remember, our f of x has two different functions. So step one, so we're trying to evaluate negative 5. We need to figure out which function to use. So is that negative 5 less than negative 2 or greater than or equal to negative 2? If you said less than negative 2, you're right. So negative 5 is less than negative 2. So we're just going to plug it into this equation. So you'll notice we put negative 5 squared. Notice the parentheses. Those are very important because when we square this, it's a negative times a negative, so it's going to turn positive. But anyway, negative 5 squared minus 1. So we just plugged our 5 into that, did our math here, and we got to 24. So if we were to do a different example, so we've got f of negative 2. So this one's kind of on the borderline. So now we need to really understand what these different symbols mean. So hopefully you remember this is less than. So it has to be less than, not equal to, but less than. This is greater than or equal to. So since this is x greater than or equal to negative 2, this is actually negative 2. So since it is equal to negative 2, we are going to use this function. So again, all we do is we take negative 2, we plug it in for everywhere where we see x. So we've got 5, we put our negative 2 in right there, and plus 3. So we do some math, we get down to negative 7. So, okay, let's actually do one together. So we're looking at 7. So we need to figure out if 7 is bigger than or less than or equal to our negative 2. Sorry, here we go. So our 7 is bigger. That's the wrong one. Our 7 is greater than negative 2. So we're going to be using that bottom one. So, and we're just going to plug 7 in for wherever we see x. So we're going to have 5 times 7 plus 3. 5 times 7 is 35. So we have 35 plus 3, 5, 6, 7, 8, 38. So at this point, it is just taking the number, figuring out which equation to plug it into, and then plug and chug. So let's try some graphing. Okay, so graphing, it's the same general idea, but just, you kind of got to pay a little bit closer attention about where your borderline is. So again, all you're doing is you're going to graph this function on one side of negative 3, and then this function on the other side of negative 3. Conceptually, that's it. But the way it looks, it does get a little, you can get lost in the weeds pretty easily with these. So what I usually do, you don't have to make a borderline but I will usually look at this part right here, and it says x is less than -3, and then if we got x is greater than -3. So I'm going to draw a dotted line at -3. 1, 2, 3. X equals -3, by the way. So this is kind of a pretend line. It doesn't really exist. That's why I made it dotted. But it kind of helps me with my graphing. So then on the left side of -3, so that means that if x is less than or equal to -3, this is the equation that I'm going to use. So that's the same as saying y equals x. So if we have that equation y equals x, I'm just going to write that out real quick. So our y-intercept is going to be 0. This is just a pretend dot though, because the only thing we care about is to the left of this dotted line. But we still need to graph the whole line, right? So we've got, what did I say? If y equals x. So we've got our y-intercept is at 0. So then our slope is going to be up 1 over 1. Well, in this case, I'm only concerned about this part over here. So instead of going up 1 over 1, I'm going to go down 1 to the left 1. So if I were to kind of make some guiding points, so then here is where the line is actually going to start. We're going to put a solid dot, because this is less than or equal to. And then we're just going to finish out my line. So we got my solid dot. Kind of like that. So you will notice that the line does kind of go up here, but I don't actually care about anything past this dotted line. So the only part that I need to put for real, quote unquote, is this part right here. So this part we just make up for like guiding purposes, because that's just how we graph lines. So, okay, let's do the other one. So now this one we'll do in blue. So this is for x is greater than -3. And this is our equation. And that's basically like y equals -2x plus 1. So our y-intercept is going to be at 1. And then our slope is down 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Let's see, and then we're just going to connect these dots. We'll call that good. So up here on this dotted line, we're going to do an open circle, because this part right here is x is greater than -3. It does not include -3. -3 is included down here, but not up there. So that's where you have to pay attention to your symbols. So then we're just going to finish our line over here. Put an arrow, means it goes on forever. And there we go. So there's our graph. So the real parts of the graph is just this line and this line. This little dot right here, this little line right there, those are all just kind of guiding marks that I make to help us graph. So again, conceptually, you have this dividing point. You graph this graph on one side, this graph on the other side. That's it. Conceptually, this is easy, but it's hard to get into the details. So let's try another. All right, so we did forget to talk about domain and range from the last one, but that's okay. I'll pick you up here at number 4. So step 1, we're going to graph it, and then we will find the domain and range. It's hard to do that without graphing it, at least at this point, because it's hard to visualize all this stuff. But here we go. So we've got x is less than -1, x is greater than or equal to -1. So I'm going to draw a dotted line at -1. That is my border line. So on one side, it's going to be one equation. On the other side, it's going to be a different equation. So for the left, we've got x is less than -1, and we've got this guy right here. So graphing a normal line, it's already in y equals mx. We've got a point at 7, negative 7. 1, 2, 3, 4, 5, 6, 7. And then we're going to go, I'm going to go up 3 and to the left 1. So 1, 2, 3, 1. So now I've got a dot there on my borderline. So here's where we gotta look at this part right here. So it's going to be an open dot because it does not include x for this function. Okay, so then we're gonna keep going. So to the left 1, up 3, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3. And there's no set amount of dots that you have to make. You just need to make enough so that you can connect the dots and make your line pretty close to being accurate. Okay, so that's our left side of our border. So now we're going to look at our right side of the border. So this is x is greater than or equal to negative 1. And our equation is just negative 5. So we can rewrite that as y equals negative 5. Sometimes it's easier to visualize and see that. So what that means is we're going to go to negative 5. 1, 2, 3, 4, 5. And it's a horizontal line through the whole thing. But we only care about anything to the right of our purple borderline. And this time our dot is going to be a closed dot because it's greater than or equal to. So we're going to put a closed dot. And there we go. Okay, so now that we have a graph, we can start kind of making some meaningful judgments about like the domain and range. So again, domain is all possible x values. So we are looking at any kind of x that could cross. So I'm using this horizontal line because this would represent this x value, and if it crosses the graph somewhere, then that is a good value. So that's kind of why I do these lines. But so a couple of places you always need to check with these piecewise functions. So one, okay, this is a line, got it. So this goes on forever that way. And this one goes on forever that way. So initially our domain that we would kind of think about is all real numbers, right? But we need to check one part. We need to check the boundary. So this part right here is where things can get a little strange. So this time, since that value is included in one of them, then it is in fact going to be all real values. So that's fine, that works. Sometimes though, when like both of these are going to be open circles, there might be an exception where that value is not counted. So our domain is all real numbers. So our range is going to be a little bit more interesting to figure out. So I'm going to use kind of horizontal lines. So this goes on forever. So it goes on up forever. But there's a limit to with how low it goes. So it goes all the way down. Now notice this part is an open circle. So this value right there, which is what? 1, 2, 3, 4. So at y equals negative 4, that is not one of the values. So you can't include that in the range. So the way I would write it, if I'm going to do interval notation, I guess I need to start from the smallest, work my way up. So if I come up through here, so this part hits, so we have this line right here. So I need to write that down. So make my little curly brackets. And so that's going to be at y equals 1, 2, 3, 4, 5. So I'm going to write y equals 5, comma, and I use y equals 5. It's a horizontal line. I'm sorry, negative 5. Sorry. So then now we have to deal with the red line. So the red line starts at negative 4 but does not include negative 4. So if I were to write that as an interval, I could write that as negative 4 to positive infinity. Now remember, the parenthesis means that that value is not included. Normally, how we would write the connecting part in math, we would actually move this over here, and we would use just, it's not a U, but it kind of looks like a horseshoe. So that is just kind of the mathematical symbol for and, if you will. And then we can close our bracket. So another way to write this, if your brain thinks that way, another way to write this is y is greater than -4. And then if it included -4, you would do greater than or equal to. But in this case, it would just be y is greater than 4. I'm cool with either one, as long as you're right. It's just two different ways to express the same answer. So either one works. So there's our domain and our range. Remember, domain x values, range is y values. So let's do another one. All right, so here we are at number 5. I took the liberty and already graphed it. So this is my top red line, this is my blue bottom line. And so here's that kind of situation I was talking about. Look carefully at both of these. They are both open circles. So when we're talking about the domain is normally all real numbers, except it's all real numbers except for this line. So the way we can write that, now, yes, you should learn the mathematical language, but as long as you express to me the right answer, you're good to go. But the way that you would write that would be x such that, it's that solid line, x does not equal 2, close bracket. And so that insinuates it's all real numbers except for 2. So, okay, now let's look at our range. So again, our range is our y values, so we can start up here, crosses both lines twice. Now here, it doesn't cross the blue line, but really that doesn't matter. The range is just possible y values. So this value is good because it crosses right there, which means we can keep going down and our range goes all the way down to this value. So the way we would write that, we can write that multiple different ways, but to keep to with the way that I started, we're going to do our open brackets, and it's going to be y such that y is greater than whatever number that is. I don't know. 1, 2, 3, 4, 5. -5. And again, the other way to write this is you can do it as an interval. It would go from -5 to positive infinity. Both of them are equally as correct. I generally prefer this one because I think it's easier to write, but it doesn't really make a bit of difference. All right, so number 6 is, again, another good one to go through because there's 3 different equations. It's the same process. It's just chunked up into 3 different sections. So you'll notice that I made my dotted lines. And again, those are kind of like fake dotted lines, just giving me my boundaries at -5 and then at 1. So here's my -5, here's my 1, and that just gives me some references to use. So after that, you just graph each one individually, but you only really draw the parts of the section that matters. So this is the far left, this is going to be the middle, this is going to be the far right. So we look at the far left, and our equation is -1, so we would just say y equals -1, which is a horizontal line going like that. Here is a normal line. We found our y-intercept, and then our slope is -1 over 1. So we went down 1 over 1 and drew our slope. And what else? To the far right is going to be this guy. So it's going to go just right up there. Again, it's y equals 6. It's another horizontal line. So then we can talk about the domain and range again. So the domain is all possible x values. So let's see here. where am I at? So if we, again, look at the borders. Those are going to be where kind of like weird things happen. So right here, it does cross right here. This is a solid dot. Okay, so we're good. That value works. And it does cross here. Again, our solid dot is up there. So our domain is going to be all real numbers. And we'll put that in curly brackets because that's kind of the right thing to do. So then our range is going to be a little bit more interesting. So it starts, if we start from the bottom, okay, these don't cross. It starts crossing right here, but it doesn't include this value, which is 1, 2, 3, y equals -3. So we can write from, what is that? -3. And then as we go up, so this line right here, it does still cross right there. So it crosses more over here, but that's fine too. So it keeps going up. So it's gonna be -3 to 1, 2, 3 to +3. So I'm using interval notation this time. The parentheses means that it does not include that value. So then we have this part up here that we have to deal with, and that is just going to be y equals 1, 2, 3, 4, 5, 6. Y equals 6. So we'll put our little U connecting part right there, and we're good to go. All right, 2 more. Once again, we've got 3 different equations going right here, and it looks like 2 of them are normal lines. This guy's going to be a horizontal line. So here we go. So we've got a boundary at -2 and then 4. So I made my dotted lines. So my far left is going to be this guy. So 2x, so that would be like y equals 2x. So I started my y-intercept is at 0, and then I used my slope to figure that out. But notice that I didn't start really drawing until I got to my boundary. This is less than or equal to, so this is going to be an open circle. I'm sorry, a closed circle. That's what I meant to say. So then our middle part has got 2 boundaries. They are both less than and less than. Neither one of them have an equal to sign on it. So that means this is going to be an open dot and an open dot, and then I just graphed this line in between, and y equals -3 over here is going to be a horizontal line. So I'm looking at this part right here. I see a greater than or equal to sign. So this has a closed dot. So let's talk about domain. So I'm looking at possible x values. So I can use big, long lines. So let's look at our boundary. Does it cross on the boundary? The answer is yes. So it crosses right there because it's a closed circle. So then it keeps going through the blue line. And again, another boundary. Where does it cross? Right there, because it has a closed circle. So in this case, our domain is going to be all real numbers. So our range is actually not as hard as you would think with 3 things going on. So as we come down, which if we're in interval notation, we should go bottom to up, but whatever. It starts here, but it does not include this value because it's an open circle. So I could write something like y is less than, what is that, 1? 1. So then we keep going down. Here it crosses twice. Great, it still crosses. Now the blue line goes further than where the red line starts. So that means that there is complete kind of coverage, if you will, as you go all the way down. And this goes on forever down into infinity. So in that case, we're kind of done. So the entire range is y is less than 1. So if I wanted to write that in interval notation, I would do -infinity. You always start from the bottom, go up, and up to 1. 1 is not included. -infinity is never included because infinity is not a real number, it's a concept. Number 8, let's do all together, all, the whole thing here. It's our last problem, so you're almost there. Here we go. So I've got, I like using different colors. It makes things interesting. So I'm going to make my boundaries in purple. So I'm going to do that first. So I've got a boundary at 0. I kind of had to go off just so I could see the dotted line a little bit. And then I've got another boundary at 6. So 1, 2, 3, 4, 5, 6. Okay. So now we're going to make this guy red, the two outsides red, the middle one blue. And so my far left, so that is like y equals -3, or y equals -3 plus 0. So 0 is going to be our y-intercept. So I'm going to put a small little dot there. And then our slope is going to be, let's see, I want to go to the left. So I'm going to go up 3 and over and to the left 1. So I'm going to say that my slope is like 3 over -1. Rise over run. So we're going to go up 3, 1, 2, 3, and over 1. 1, 2, 3, over 1. So there's our line. So now what kind of dot are we going to put right there? So if I'm looking at this, there is no equal to sign, so that is going to be an open dot. Oops. An open dot. Anyway, okay, so now we're going in the middle. So our y-intercept is going to be -1. So I'm going to come over here to -1, make a little makeshift dot for now. I'm already looking at this, so I can even make this a closed dot, make it a nice big dot. So now our slope here is going to be down 1 over 2. So I'm going to go down 1 over 2, down 1 over 2. And then this sign right here means that this is going to be an open circle. So let's just connect those dots. Okay, last but not least, y equals -7. -7 is going to be our y-intercept. 1, 2, 3, 4, 5, 6, 7. And then our slope is going to be 1 over 1, so up 1 over 1. So notice how I'm just kind of making these dots here, but I'm not really going to start drawing for real until we get right here. And that's where my boundary was. I'm just going to leave that line as being weird looking. So there's our graph. So now we can start talking about our domain. So if I just look at the lines, line, that kind of sort of should be all of them. But so let's look at our boundaries. So we look right here. This one's good. But we look right here. This one is not good. So there's a break in between here and there. And this value is no good. But everything over here is, and everything over there is. So we can write our domain is x does not equal, I don't even know, what is that? 1, 2, 3, 4, 5, 6. Does not equal 6. And technically, if we wanted to be super mathematically correct, we would write x such that x does not equal 6. And that insinuates all values other than 6. So our range, we're going to do the same thing. We're looking at our horizontal y's. So if we come up from the bottom, nothing, 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 and it starts right here, but it does not include that value. So then it goes. It hits right here, so we're good on that one. But then it stops. It's hard to see, but it stops right here and starts again going up at, what is that, y equals 0. So we're going to say, going from the bottom up, what is that, -1, 2, 3, 4. So -4 to -1. Notice the square block right there, and that is because this is a closed dot, so that insinuates that the -1 is included. Then we're going to do our U sign, and then that starts at 0. but it does not include 0 and goes up to infinity. So there you go. You made it through another one. I'll see you in class.